Hello, class. Welcome back to Eureka Math. This is 8th grade. We're in Module 4, Lesson 29. This lesson is called Word Problems, where we're going to be solving word problems about systems of equations. We've been working with systems of equations since Lesson 24. Let's use our knowledge to solve some word problems. So you'll need pages 359 through 367 of your workbooks. And like always, you are in control of the speed of the video. If you need to pause the video to write anything, if you need to go back and rewatch, do that. Do whatever it takes for you to succeed. Well, let's start with the vocabulary for this lesson. We got two terms today, and both of them we've seen before. First term is system of equations. A system of equations includes two or more linear equations that are related to the same problem. Two or more equations that are connected. And we connect them with this bracket. That's how we know it's a system, if the equations are both in a bracket. Like this, y equals mx plus b, or we can have ax plus by equals c, standard form. If you have two equations in a bracket, that is a system. Next word is solution to a system of equations. A solution to a system is the set of coordinates that make all system equations true. So it's coordinates that make all equations true. So it works for everything in the system. In other words, it's where the lines intersect. So if you graph the equations, where they cross, where they intersect, that is the solution. And it is a set of coordinates. So you write a solution by a set of coordinates, and you can find it by graphing and seeing where they intersect. We also learned how you can find it using the substitution method and the elimination method, which you might need both of those today. Speaking of today we'll use our knowledge of systems to translate word problems into systems of equations, and then solve them. So we're going to get a word problem. You're going to translate the word problem into a system. So you're going to take a word problem and make two equations in one system. And then you're going to solve that system to solve the word problem. So I do have some steps today. Step one for this work is to read. Read the problem, read it carefully. Because step two is to translate. And to translate, you really have to understand what the problem is asking. So read first and then translate into a system of equations. So you should get two equations at least from every word problem. So try to think about where the two equations are. And then third step, you solve the system that you made to answer the word problem. Now, solving the system will not always answer the word problem. Sometimes there might be an extra step or two that you'll have to think about when you're coming up with your answer. So the solution to the system might not be the answer to the word problem. So the solution, I'll say it again, the solution to the system is not necessarily the answer to the word problem. You have to use the solution, use the coordinates to find your answer. Let's see how this works. Your examples are actually in your workbook. I did not have to write an extra page. There are three examples, I believe, and they start on page 359 of your workbook. So let's look at page 359, example one. We're going to do some examples together, and then I'm going to have you try the exercises on your own and see how well you do. Okay, let's look at example one. It says the sum of two numbers is 361. The difference between the two numbers is 173. What are the two numbers? So there are two numbers we do not know. Let's say x and y. We have two numbers. X is a number and y is a number. What do we know about these numbers? Well, we know the sum of the two numbers. So add, sum means add x and y means equal 361. So I know that if I add x plus y, I get 361. That's one of the equations in my system. What else do I know? I know the difference, which means subtract, between the two numbers. So the difference with x and y is 173, which means x minus y equals 173. So that is my system. Two equations I made from the word problem. What's the best way to solve this system and find the two numbers? Well, I'm looking at this and I remember the substitution method, I remember the elimination method, and I see right here that I think the elimination method is going to work best because I see a plus y and a minus y. Those are opposites, so I can eliminate y. So let me do that. Let me add these together to get another equation to eliminate the y. So at 1x plus 1x is 2x. Plus y minus y turns into 0. It's eliminated. And then I have to add the solution. So I get 1 plus 3 is 4. 6 plus 7 is 13. 1 plus 3 plus 1 is 5. So I get 2x plus 0 equals 534. That's 2x equals 534. That means if I divide by 2, I get 267. Let me check and make sure that's correct. 267, that would be 34 plus, yep, I'm right. 267. So x is 267, which is good. I know x equals 267. That's the first number. I still need both numbers because it's asking what are the two numbers. So to find the other number, to find y, the other number, I take my x and I put it into one of these equations. I'm going to put it into the first equation. I'm going to say x plus y equals 361. So I know 267 plus y equals 361. So now I need to use my properties to solve this. I'm going to take 267 away from both sides. That gives me y by itself. And 361 minus 267, I have to do some borrowing. I get 94. So y is 94. So those are my two numbers. If I add them together, I get 361. And if I subtract them, I get 173. So that is how you use a system of equations to find those two numbers. I read it, I translated it to make a system, and then I solved the system to find my two numbers. Now this was an example where we just had to find numbers. Let's talk about another real world example. Maybe not talking just about numbers, but talking about students at a middle school. So example 2, there are 356 8th grade students at Euclid's middle school. So 34 more than 4 times the number of girls is equal to half the number of boys. How many boys are in 8th grade at Euclid's middle school? How many girls? So they need to know how many boys and girls are here. So let's choose our variables. Let's say x is the number of girls. And let's say y is the number of boys. Now we need to come up with a system of equations using the information from this word problem. Well, the first thing they tell us is that there are 356 8th grade students at Euclid's middle school, which means if there's 356 students, we know the girls plus the boys equals 356 students. 356 students means girls plus boys equals the total. X plus y equals 356. Easy enough to do that one. 356 students, boys and girls together make 356. The more complicated one is the next one. It says 34 more than 4 times the number of girls. So 34 more than means plus 4 times the number of girls, and we said girls is X. So 34 more than 4 times the girls is equal to half the number of boys. So half the boys is Y. So there we go. 34 more than 4 times the girls is half the boys. You notice how I just took one word at a time and I translated it into math symbols. That's how you translate. It can be complicated, but with practice you can do it. So our next equation is 4x plus 34 equals 1/2 y. Equals 1/2 y. Now, you might be saying, okay, which method should I use to solve this? Well, the elimination method does not really look like it's going to work because they x and y are on the same side over here, but they're on different sides here. So I'm thinking the substitution method would work well for this. I am going to do one thing to make the substitution method, I think, a little easier. And remember, it's all about these shortcuts to make it easier later. So I'm looking at these equations and I'm thinking, what bothers me about these equations? And this 1/2 is kind of bothering me because I know there's not going to be half a boy wandering through the hallways. That would be disgusting and disturbing. So let's, because I don't know if it's going to be a pair of legs walking around or a torso walking around or maybe just split down the middle. But there's no such thing as half a person. Everybody is a whole person. So let's change this half into a whole. And I'm going to do that by multiplying by 2. If I multiply by 2, I multiply everything by 2 because that's the multiplication property of equality. 4x times 2 is 8x. 34 times 2 is 68. And 1/2 times 2 is just 1. So now, instead of an annoying fraction, I have a whole number because we're only talking about whole people. So this helps us because now we have a y equals, and I can use the substitution method because I can say that y equals, the orange y will equal the green y. In other words, I'm going to take the first equation, x plus y equals 356. Only this time I'm going to take x plus the y for the second equation, 8x plus 68 equals 356. And that's the substitution method. I just used the substitution method. I took the second equation for y and put it into the first one. Now I'm going to simplify this. X plus 8x is 9x plus 68 equals 356. I want the x term isolated, so I'm going to do minus 68 from both sides. That gives me 9x equals 288. If my math is correct, and I believe it is. And then I need to divide by 9 to isolate the x. So 9x divided by 9 is x. And 288 divided by 9, I believe, is 32. 32. So we get x is 32. Now we need to use that x to find y. So what I'm going to use, I'm going to substitute into this equation. I'm going to take this one, y equals 8x plus 68. So now I need to take the x and put it up here. So I use the substitution method we used twice. So that's 8 times 32 plus 68. So 8 times 32 is 256 plus 68. Let me just check my math. 8 times 30 is 240. 8 times 2 is 16. 240 plus 16. Good. Now I do 256 plus 68. That's 224, I believe. No, that's 324. I'm sorry, 324. Forgot to carry. So 324. So now I know that there are, I use this information, there are, at this middle school, there are 32 girls and 324 boys. And that is a good ratio for the girls who are interested in boys, because there's apparently a lot of choices for the girls. Not a lot of choices for the boys are interested in the girls. But somehow that's the way it goes. So that is how we solve this. Again, we read, we translated, we solved, and we put our answer in the real world terms. Let's do another example. Example 3. Oh, I guess there's 4 examples. I thought there were only 3. Okay. Example 3 on page 360. A family member has some $5 bills and $1 bills in her wallet. So she has $5 bills and $1 bills. Altogether, she has 18 bills. So she has 18 bills and a total of $62. Okay. So let's assign our variables. We need to know what x is going to be. Let's say x will be the 5s. And let's say y will be the 1s. X's are 5s, y's are the 1s. So x is how many $5 bills she has, y is how many $1 bills she has. And we need to solve this by translating it into a system. Now, what do we know? We know she has 18 bills altogether, which means we know her 5s plus her 1s, the number of 5 she has, and the number of 1 she has to be 18 bills altogether. What else do we know? Well, we know she has a total of $62, which means every $5 bill she has, every X is worth $5. So $5 times the number of 5s plus $1 times the number of 1s will equal $62 altogether. Because when we're counting money, we multiply $5 bills by 5, we multiply $1 bills by 1, and that's how we count our money. And she has $62 altogether. So now we have x plus y equals 18, 5x plus 1y, or you can just say 5x plus y equals 62. How would we like to solve this? You can either use the elimination way or the substitution way. I think what I'm going to do is I'm going to actually use the substitution way for this. And the way I'm going to do this is I'm going to change the equation just a little bit. This top one, I'm going to move the x over. So I'm going to get y equals negative x plus 18. You can see I just did minus x on both sides. I did minus x on this side to get y by itself, and the minus x on the other side goes with the 18. So now I have I have these equations, and I can use the substitution method. I'm going to say that y equals y. Maybe you wanted to use the elimination method and you multiplied by -1. You're allowed to do that. My strategy was to use the substitution method. So I'm going to do 5x plus y, and I'm taking the pink y, equals 62. So I get 5x plus negative x plus 18 equals 62. So let's solve it. That's 5x and minus x means I get 4x plus 18 equals 62. Take 18 away from both sides to isolate the x term. 62 minus 18 is 44. Divide by 4 to isolate the x. 44 divided by 4 is 11. So x is 11, which means she has 11 x's, so 11 $5 bills, 11 fives. Now we need to find out how many ones she has. So for this one, I'm going to take the first equation, x plus y equals 18, except I'm going to do this x plus y equals 18, which is 11 plus y equals 18. So to get the y by itself, I just do minus 11 from both sides. 18 minus 11 is 7. So she has 11 x's, 7 y's, which means 11 x's is 11 fives. 7 y's is 7 ones. That's how we know what she has in her wallet. We made a system of equations, and we use a substitution method to solve the system. Once you get the hardest part of this might be writing the equations, but that takes practice, which is why we're here. Let's do example 4, our last example, before you get to try a little bit yourself. A friend bought 2 boxes of pencils and 8 notebooks for school, and it cost him $11. So 2 boxes of pencils, 8 notebooks was $11. He went back to the store the same day to buy school supplies for his brother. He spent $11.25 on 3 boxes of pencils and 5 notebooks. And the question is asking, how much would 7 notebooks cost? You notice it's not asking how much does 1 box of pencils and 1 box of notebooks. It's asking how much would 7 notebooks cost. So we just care about the notebooks. We don't care about the pencils. But we need the pencils to help us solve this equation. So let's pick our variables. Let's say x is going to be a box of pencils, and y can be a notebook. A notebook. So let's write a system using what we know. So it says he bought 2 boxes of pencils, so that's 2 boxes of pencils, and 8 notebooks, so that's 2 x's and 8 y's, and it equaled $11. And then he went back later. He got 3 boxes of pencils, so that's 3 x's, and 5 notebooks, so that's plus 5y, and it cost him $11.25. Well, that's useful to know. So right there, we already know our equations. Now we need to think about what we need. We need to know 7 notebooks. So what I need to find is the notebook. I want to find the y. I don't need the x. So what I'm thinking of doing is I'm thinking of using the elimination way to make the x go away. I want the x to disappear because I don't care about the x. I want the notebooks because I want 7 notebooks. So let's make the x go away. To do this, you can see, okay, well, the elimination method might be a little bit tricky here because these are not the same. But I can make them the same. I'm just going to take this one and multiply it by -3. And I'm going to take this equation and multiply it by -2. And that, let me show you what I just did. I get 2x times -3 is -6x. 8y times -3 is -24y. And 11 times -3 is -33. And then the other equation changes. I'm sorry, I'm not doing -2. I just want to do +2. I'm sorry, I made that's a mistake. I'm multiplying the top one by -3 and this one by 2. 3x times 2 is 6x. 5y times 2 is 10y. And 1125 times 2 is 22.5. Now you'll see right here, the reason I did this is because now I have negative 6x in the first equation, 6x in the second equation. Those can be eliminated. I can eliminate them. Those, when I add the two equations, this turns into 0. The x's are gone. Negative 24y and 10y turns into negative 14y. And negative 33 and negative 22 is negative 10.5. Now, it is okay right here to probably use a calculator because I'm doing it in my head, but I'm pretty sure I'm right. But for this next part, where I have negative 14y equals negative 10.5, I might want to do a calculator for this one. So, because I need to divide both sides by negative 14. Negative 14. So let's do this. I do negative 10.5 divided by negative 14, and I get 0.75. So y is 0.75. So that 1y is 0.75, which means one notebook equals 75 cents. I just found that out. But remember, I don't care about one notebook. I want to know 7 notebooks. So I take the 75 cents and I multiply it by 7 to find how much 7 notebooks cost. Seven notebooks is going to be $5.25. That's the answer to my question. You notice I never talked about how much boxes of pencils were. Could I tell you how much the pencils are? Yes, of course I could. I just need to take the y and put it into one of these equations. But because the problem is not asking how much boxes of pencils are, I'm not going to do it. I don't have to. It's not part of the problem. You can do it if you want to, but I'm not. So those are the examples. Hopefully you got a little bit of practice. Hopefully you saw a little bit about how to translate, make a system, and then like I did up for example 3, I changed the equations a little bit to use the substitution method. And for number 4, I changed the equations a little bit to use the elimination method. It's all about making it easier for yourself, using the properties we've learned. Like for this one, I use the subtraction property of equality to make it easier. And for this one, I use the multiplication property of equality to make things easier. Use the properties you know to make a life a little bit easier when you're solving these systems. What I would like you to do now, turn the page to page 361. And we have a few exercises. Let's see, exercise on 361 and 362. There are 3 exercises that I would like you to try yourself right now. So pause the video, try the translating and the solving on your own. Unpause the video when you're ready to check your answers for all 3 exercises. So try the 3 exercises and then unpause to check your work. Okay, so hopefully you took some time to pause the video, try the exercise on your own. Now I'm going to solve them, and we will see how well you did. So exercise 1. A farm raises cows and chickens. The farmer has a total of 42 animals. Total of 42 animals. One day, because I guess he's bored, he counts the legs of his animals and realizes there are a total of 114 legs. How many cows does the farmer have? How many chickens does the farmer have? Okay, so instead of counting the different animals, he just counts legs. Okay, this is kind of a weird farmer, but we can work with this. We can use the system of equations. First step is to choose X and Y. So we're talking about cows and chickens, so let's just do cows can be X, and chickens can be Y. Why not? Now we need a system, 2 equations that talk about the farmer. Well, first we know he has a total of 42 animals. So we know his cows plus his chickens equal 42. We know that. Just what that is. Then the legs of his animals has 114. Now, legs. Well, cows. If you're counting legs, cows have 4 legs. So that means if we're counting legs, we do 4 legs times the number of cows. Plus, chickens have 2 legs and 2 wings. So they only have 2 legs. So if you're counting chickens, you multiply 2 times the number of chickens. So 4 legs times the number of cows plus 2 legs times the number of chickens equals 114 legs all together. So now we have our system of equations, and we need to come up with a way to solve this system. Now, we can do a couple different methods here. We can use the substitution method, or we can use the elimination method. I'm looking at this, and I'm thinking that I want to do, you know what? Well, you have a couple choices. I don't know what you did. If you did the elimination method, you probably multiplied this equation by -2. You multiply this equation by -2 so you can cancel the y's. If you did the substitution method, you changed the equation. I would have done this one, y equals, and then do 42 minus x. So I'm looking at this one, and I think what I want to do, let's do the elimination method. Why not? So I'm going to take this equation, and I'm going to do multiply by -2. Let's show you what that looks like. We have a new system. We get multiply by -2. So -2 times x is -2x. -2 times y is -2y. And 42 times -2 is -84. The other equation stays the same. I'm not going to change that one. And the reason I'm not changing it is because you can see right here, I'm going to cancel the y's. So let's add these equations together, cancel the y's. -2x and 4x just turns into 2x. -2y and 2y is 0. That's what gets canceled. -84 and 114 is 30. 30. So I get 2x equals 30, which means x is 15. So I know he has x is 15. So I know the farmer has 15 cows. Now I need to find y. So I'm going to take this first equation. X plus y equals 42. But this time I'm going to say, well, I already know x. So I'm going to take x, the green x I found, plus y equals 42. So that's 15 plus y equals 42. So all I have to do is subtract 15 from both sides. I get y by itself. And 42 minus 15 is 27. So I know he has 15 cows because x equals 15, y equals 27, so he has 27 chickens. And that is the answer to our, as the answer you should have got, even if you did the substitution way. I can try to squeeze in the substitution way. Let me try the substitution way. If you did the substitution way, so this is option 1. Let's show you option 2 with the substitution way, just to prove to you that it works both ways. I'm not going to show you both ways for all the exercise, but this one I have time. So if you did the option 2 way, you got y equals 42 minus x, and you got 4x plus 2y equals 114. And for this one, you're going to do y equals y. You're going to use this. Option 1 was elimination. Option 2 was substitution. So you get 4x plus 2, and we're going to use the pink y, equals 114. So you get 4x plus 2 times 42 minus x equals 114. So let's do that. 4x plus 84 minus 2x equals 114. 4x minus 2x is 2x plus 84 equals 114. 2x equals 30. X equals 15. So that's the exact same answer we got here. Same there. So you can see elimination method gives you x equals 15. Substitution method gives you x equals 15. Does not matter which option you choose. So you can see whatever option you choose, you get the same answers. So this is if you did the elimination way, you did it this way. If you did substitution, you did this way, and then you finish with the orange. Let's check your work on exercise 2. The length of a rectangle is 4 times the width. The perimeter of the rectangle is 45 inches. What is the area of the rectangle? Okay, so for this one, I'm actually going to draw a diagram because it is a rectangle. So here's my rectangle. And we have the length and the width. So let's do the length can be x. The width can be y. And so we have x is the length and y is the width. Now, let's turn this into a system. The length of a rectangle. So x is 4 times the width, 4 times y. The length is 4 times width. So x is 4 times y. That's why it's always important to do your variables first. If you do your variables first, writing the equation gets easier. So we know x equals 4y. And then the next piece of information says the perimeter of the rectangle is 45. Well, for this one, you need to know what perimeter is. Perimeter is going all the way around the rectangle. So we go all the way around. It's adding all the sides. So when we add the sides, we have 2 x's plus 2 y's all the way around. Add 2 x's, add the 2 y's, and we get 45. Now it needs what is the area of the rectangle. So it's asking us the area is the question mark. Now the area of a rectangle is length times width. So for the area of the rectangle, we need x times y. So to answer this question, I need x and y because they get multiplied together to find my answer. So I need x and y. But so let's use this system to find x and y. You're looking at this, and the obvious way to do this for me is the substitution method, because I already have x by itself. So I'm just going to say that x equals x. That's the substitution method. So I'm going to take the second equation and put the first equation inside of it, just like that. 2x plus 2y equals 45. So I get 2, and remember the green x means 4y, plus 2y equals 45. Well, 2 times 4y is 8y, plus 2y equals 45. So that's 10y equals 45. Divide by 10, y is 4.5. Easy enough. So y, the width, is 4.5 inches. Now but remember I need x and y to find the area. So let's take the first equation, x equals 4y. Only now x equals 4, and I'm going to use the y part of my solution. So I get x equals 4 times 4.5. So 4 times 4.5 is 18. I did it in my head. You can use you might have used a calculator when you did your work. So now I know the length x is 18 inches. The width y is 4.5 inches. That still does not help me with my answer because I need the area, x times y. So I need to do 18 times 4.5 to find the area of this rectangle. 5 times 8 is 40. 5 times 1 is 5. Plus 4 is 9. 4 times 8, line up the place value with the 4. 4 times 8 is 32. 4 times 1 is 4. Plus 3 is 7. Add up the pieces. Move the decimal one place value. The area equals 81 inches squared. That is the area of that rectangle. And that is what you should have gotten if you follow the steps I did. Remember, I drew a diagram. I labeled my variables. I wrote my equations. I used the substitution method to find y. Then I used the substitution method again to find x. Maybe you wrote your equations a little bit differently, but maybe you said y equals 4x, whatever you used. You got the same y, the same x. Then you multiplied them to find the area. Multiple step problems, but if you do one step at a time, take your time and focus, you should be fine on this. Hopefully you're getting some practice. Hopefully you're doing it right. If you did not get this one, go back and look at my work again. Watch me do it again to see maybe where you made a little bit of a mistake. If you're still stuck, remember, you can always ask me for help. You did one more exercise. You did exercise 3. So let's check your work for exercise 3 on page 362. Exercise 3 says the sum of angles x and y is 127. Well, that's easy. They already gave us the variables. X is an angle, and y is an angle. That's simple. And we need to turn this into a system. The sum of measures of angles x and y is 127. If the measure of angle x is 34 degrees more than half the measure of angle y, what is the measure of each angle? So we need to know the measure of each angle. So we need both angles in our answer. But the first one says the sum of angles x and y is 127. So add x and y is 127. So I'm going to do x plus y equals 127. Next equation is a little bit trickier. So x, the measure of angle x. So x is 34 more than, add, half measure of y, half y. So x is 34 more than half y. You see how I just translated one piece at a time, changing English language into math language. So I get x equals 34 plus 1/2 y. There we go. I have two equations, and now I can solve them. And what I'm thinking I'm going to do is I think I'm going to use the substitution method because I already have x isolated. Because I have x isolated, I think I can do it. I think I'm going to use x isolated. Although I'm thinking on this, would it be easier to make the half go away first? Would that be easier? And I'm thinking, yeah, I think I want to make the half go away. Maybe. Do I want to do that? You know what? Let's make the half go away. It's not a bad idea to get the fraction out of there and make things easier. Maybe the fraction will come back later. But what I'm going to do is I'm going to multiply this equation by 2 to make the half go away. So I get, after I do that, remember the multiplication property probably says multiply everything. I'm sorry, I said that a little bit fast. The multiplication property of equality says multiply everything by 2. So I get 2x equals 68 plus y after I multiply by 2. 2x equals 68 plus y. Now what I'm going to do is I still want to use the substitution way. So let's change this top equation. Let's use the subtraction property of equality and get y equals 127 minus x. All I did is I did minus x on this side, minus x on that side. But now I can use the substitution property. I'm going to say that y equals y. So I'm going to take the brown equation, 2x equals 68 plus, I'm going to move in the pink y. So now I take this stuff and put it there. So I'm going to get 2x equals 68 plus 127 minus x. Substitution method right there. Let's solve this. 2x equals, let's see, 68. That's 195 minus x. I need to add x to both sides to move this x over here. So I get 3x. Add x over here, get 3x. Add x over here, it cancels. Then I need to do divide by 3. 195 divided by 3 is 65. And you were allowed to use a calculator if you want. I did not, but you can. So x is 65. So that means angle x equals 65 degrees. We still need to find angle y. So to find angle y, let's just put it back up here. Let's use this one. Y equals 127 minus x. We did that right here. Only this time I'm going to substitute the solution x to find the solution y. So I get y equals 127 minus 65. So y ends up being 62. 62. So what angle x is 65 degrees, angle y is 62 degrees. I like that. I think it was a good idea to get the 1/2 gone. So that's something I always like to do. If I see a fraction, I like to make it go away and then think about how to use a substitution, what method to use after that. So it just makes the math a little bit easier if I don't have to deal with fractions, which is why I did that. Maybe you did this. Maybe you forgot to make it simpler for yourself. That's absolutely okay. What's important is, did you get these for the angles? If you did, congratulations. If you did not, go back and see maybe what you could have done differently and try it again on another piece of paper. But now let's talk about what your independent work is going to be like. Page 363 is the exit ticket. You'll do that last. Slide it to the back. You do have a homework helper on page 365 and 366 where they give you, let's see, 3 more word problems you can work on. So you got 3 more practice problems where they show you the work, they show you what they're thinking. Very useful, especially the thinking about how to change the problems into systems. So use the homework helper. Your problem set, 6 more word problems that you're going to solve are on page 367. This is your practice. Remember, my answers to the problem set are on the Google Classroom. On the Google Classroom. I don't know why I'm slurring. They're on the Google Classroom, so you can check your answers with mine. You can see how well you're doing. And if you get stuck, you can always ask me for help, and I'm excited to help you on anything. You just have to ask. After you check your answers and after you feel confident you know how to solve these word problems using systems of equations, then go back to page 363, and you have 2 word problems on your exit ticket that you can work on. 2 word problems that you have to turn into systems and solve to answer the questions. Again, if you need any help, remember to reach out to me, talk to me, ask me for help. I'll be happy to help you. But keep working hard. Do not give up. Persevere. All those good things that all mean the same. And have fun.